Welcome, everybody. Welcome to the Open USD Insiders live stream. This is actually an Isaac Sim office hours. Super excited to have everybody here. Welcome. It's so fitting that we have this as the first live stream of the year, straight off of our CES announcements. A lot of it focused on robotics. Eric, I'm honored to be with you here today, my friend.
It's good to be here.
So, we made a lot of announcements at CES. Let me see. I'm showing the wrong screen, I think. Let me fix this. We made a lot of announcements about robotics. Obviously, that was a big part of our CES.
Sorry about that.
That's okay.
Okay.
We made a lot of announcements at CES. We're going to post a link to the blog and with a breakdown of all the different areas that were touched on. So definitely take a look at that. But robotics was definitely a big part of it. And I think it's so fitting that we start this new year with a kind of an office hours on how to get started with reinforcement learning. And the prerequisite, Eric, is that you basically just need to install Isaac Sim and Isaac Lab, correct?
Yeah. Awesome. Let me think about that if there's anything else. Yeah, Isaac Sim and Isaac Lab.
Okay, cool.
And let me share a link real quick for in the documentation. So Isaac Lab is really nice documentation. And let me see here, local installation. So I'm posting a link to YouTube. There's the documentation, and it has installation instructions for you. And I think the other prerequisite is I've found it easier to do this stuff in Linux so far.
You have,
and
yeah.
So, yeah, in Ubuntu 22.04. And
okay,
that's what
good.
I'm finding. And especially when you start to also work with the Jetson, if you're going to real world and working with the Jetson, it's nice to have and working with ROS and all that. Now we are working you can get it all to work in Windows, but sometimes you've got to jump through a few more hoops.
Okay, so for the purpose of demonstration, we're going to be focusing on people who are using Linux.
Yeah, and I would say that from what I've seen, most roboticists use Linux.
They are, yeah.
Yeah.
Okay, cool.
So you're just going to be going with the flow a bit more if you're using Linux, or having to figure extra things out if you're using Windows for this stuff, I would say.
Okay. Awesome. Great to see some familiar faces in the chat.
Yeah. Oh, yeah.
Lychee, Shane, awesome. Scott Dempsey, aka Sirens, thanks for joining us. Krista, hey Krista. Bunch of people are actually very active in our CES announcements too. So they were all watching with us there. If you have any questions throughout this live stream, absolutely leverage the live chat feature we've got here. We'll try to hit them as we go. And let us know if you're working on something relating to what we're talking about. We'd love to hear about it. So feel free to share it with the world there in the chat. Let us know, how others may be able to help you. And obviously, we strongly encourage everybody to leverage the Omniverse Discord server for discussion with other community members and with Eric and others on the team following this live stream and anytime. We actually have a thread dedicated to this live stream. I'll post a link in a second. So you can, if it relates to what we're talking about today, you can just focus on that one thread for your posts. Okay, cool. And here's a reader right now, a viewer, put this on the screen.
Oh,
he started with zero knowledge. So this is perfect for him, right?
Yeah. Yeah, this is definitely, we're going to be doing a very early introduction to reinforcement learning using Isaac Sim and Isaac Lab. So this is meant for people who are just starting out, which, I mean, I'm just starting out myself. And so I can only be, So that's, okay. And so I've kind of been going through some pain points on my own as I've been learning, and I've kind of, forged ahead, and now I'm circling back and showing everyone what I've learned. Right.
That's great. That's perfect.
And Shane had something he's talking about. I just want to point out that, if you have to use Windows, you can make it work. And it's just a few extra hoops. And I would say that Windows subsystem for Linux is getting better and better. And I even heard a rumor that now you can pass your GPU through to WSL. And if that's the case, then it's just, you've got Linux running in Windows if that's the case. And essentially, and it wouldn't at that point it wouldn't matter if you're using Windows or Linux. So that's actually something I'm going to do this week is switch over to my Windows boot and see if I can get do a direct pip install of Isaac Sim directly into WSL on my Windows box. So I'm basically using Linux on my Windows machine as almost like a standalone black box. So let's see. I'm going to get started, but Edmar, if you see, please ask questions. Robotics is one of those things where there is so much jargon and it's so deep that even like I don't even remember what I didn't know a week ago, let alone 2 weeks ago. And so if you guys would keep me honest and be like, Eric, you're using too much jargon. Eric, we don't know what that is. And I think, and if you're still lost after this live stream, I hope you'll join us for the office hours on Discord. And there we have
the study group.
Yeah, a study group. I mean, yeah. And we have this policy that in the office hours, if you have a question, you raise your right hand. If you have a comment, you raise your left hand. If you're completely lost and have no idea what to even ask or say, you raise both hands, and we just stop and figure out where we got lost. So
that's great advice. Yeah, the study group takes place every week, actually, on Wednesdays. So we have a couple of different study groups. One is focused on OpenUSD, which happens on Tuesday, and the other one is focused on Isaac Sim and Isaac Lab, which happens on Wednesday. You can add either to your calendar by going to our own add event calendar and just looking to see what's upcoming. You can also look on our Discord server. I pasted a link a second ago in the chat. Please join if you're not already a member. And events in the upper left will list the upcoming study groups. So that's great. Great suggestion.
We got a question here. Yeah, is there an example of using the Franca arm with Move It? Example of ROS2 on Isaac simulation. I don't know that I have not seen that example with ROS2. The Franca arm examples I've seen are using more like direct coding technique, like directly interacting with the ARM through the Omniverse APIs. Yeah, but with that, let's just talk a little bit about maybe if we have some absolute beginners, let's talk about what is reinforcement learning first. And reinforcement learning is just teaching. So with artificial intelligence and learning, I think most people are familiar with supervised learning. In supervised learning, you would curate a data set of maybe like images and then what an AI should deduce from an image. You curate that collection of images and you use that to teach an AI what to do with images or something. And supervised learning is really good at kind of interpolating. So you give it this like set of images and you give it some new images kind of in the middle of that, and it can tell what to do with that because it was kind of in the middle of this curated data set. And that's really great especially for things like object detection and classification in particular, but it can be used for lots of things. Now, another type of learning is unsupervised learning. And unsupervised learning is what you'll see with like ChatGPT and large language models. And there you're just giving this AI an absolutely massive data set where you don't even know what structure there might be in there. And unsupervised learning is really good at kind of exposing hidden structures to things. And that's why LLMs are so cool. It's because we can't even come up with a great structure for describing how the human language works. But we just gave these AIs so much data and just let them train for so long that they kind of came up with that structure on their own. And so that's what unsupervised learning is really good at. And then you've got imitation learning. And imitation learning is kind of like supervised learning, but you're generating those data sets by doing stuff. And a lot of people are using that to like train humanoids. So you do things and you have people do these tasks, and then you have the teach the robots to kind of mimic those tasks, and they can teach to kind of it's kind of a form of supervised learning, I would say. Like, given a scenario, you show the robot what it should do, and then we have reinforcement learning. And with reinforcement learning, you don't start with a data set. You just start with kind of a reward system. So you kind of give your AI a scenario, and it doesn't even have to be a robot, but you give your AI kind of, this is like a scenario that will happen. And then you say, if you do these things or those things, then you'll get rewards. And you train AIs based on these reward systems, and you train AIs to get the best rewards they can. And that's what we're talking. And the cool thing about it is you don't need to be able to generate a data set. You don't need to be able to, it's just, and you're not looking for some kind of behind the scenes structure. You just maybe know what you want the robot to do, and you can train a robot based on that. And so, but you need to have some kind of a framework that says, well, given an AI, we want to do something like a robot, and we want to define, well, what observations does the robot need to make, and what actions should it take? Like, you can track the actions it takes kind of as it goes, and then you track, well, how well does it perform? And we need a framework that kind of does these simulations. They're not always simulations, but in our case, they're simulations. But it runs these simulations and it tracks all that. It makes a robot do things. It tracks. It takes observations for the robot from the environment. It uses those to have the robot do things, and and then it tracks how well it did. And in particular, those observations are fed into a neural network, and the neural network generates the actions that the robot should take. And then we use that performance metric to guide us as we train the AI to perform better and better actions based on its observations. And let's pause here and take a breath. And I see some great comments and questions. Should we answer a few of these?
Yeah, I think that'd be great. Yeah. You want to go ahead and pick yourself?
Yeah, let's start with imitation learning is a kind of reinforcement learning that can benefit the most from Isaac's Sim Lab. I'm not sure about the cameras, and then I'd say imitation learning, it depends. That's a bit of a contested topic. Some people say it's reinforcement learning and some people don't. But I think that one difference with imitation learning, even if you thought of it as a reinforcement learning method, you'd be kind of seeing how similar it is. Like when you run a simulation or have your robot do something, you'd be comparing it to imitation learning data sets that you've collected. And today I will be talking, and most of the time I will be talking about non-imitation reinforcement learning. So, and we answered David's other comment. Do you see any other? Oh, okay. As far as a roadmap goes, I do not have a roadmap, but I have seen. Do you know? I don't know that we provide roadmaps. Do you know more about that, Edmar?
We typically don't. Generally, because we kind of try to release things as soon as we can, and there are a lot of moving pieces. And we take a lot of feedback from the community, obviously, and partners and other companies. So when we announce things, they're announced basically.
Yeah, I would say the roadmap is whatever. Like, we announce things often before we release them, right? Like, they've announced some cool new things at CES, and then I'd say that's probably the roadmap.
Yeah, now I would say actually along those lines, if you have a very a great feature request you think that would really benefit other users as well, we'd love to hear that. You can post that on the forums. And I guess we should say Isaac, for support, official support, Isaac Sim has a forum area, and then Isaac Lab, the support is the discussion area in GitHub. And then obviously, if you want to chat with other community users, other users leveraging Isaac Sim or Isaac Lab, you definitely use the Discord server. But for official support, Isaac Sim goes to the forums, Isaac Lab goes to GitHub, and you can talk to everybody on Discord.
Yeah. In fact, this next question, Steve sounds like he's working on a really cool project, and I don't know that I could. We'd have to get into the details of your project before I could answer this question. So I think this is a great. I hope you'll come to the study group.
Yeah,
because that's the kind of and participate on Discord, because that's where you can start to talk to people about it, give details, and get some help. And not only that, but if you're working with a multimodal assistant, you're going to be probably looking at LLMs. You're looking at maybe Avatar Cloud Engine and a variety of different products, and some non-NVIDIA products, I would think. And so Discord is the place where you would be able to find people who have that domain knowledge from these different domains, so you can combine those. Great stuff, guys.
Yeah, and the next Isaac Sim Isaac Lab study group is actually today. Following this actually at 12:30 p.m. Pacific, 3:30 p.m. Eastern. So I'll post a link to that in the chat now.
Cool.
Oh, so for people, it's a good question on Discord, actually. Sorry for my head moving back and forth. I get a lot of messages on Discord at the same time. It looks like Eric might be frozen. So Eric will come back in a second. But we got a great question and comment from Zia on Discord. Well, it's gotten into two parts. One is we're broadcasting on Twitch. We're actually sunsetting Twitch because we weren't seeing that many users on Twitch, and we want to keep all the conversation kind of as vibrant and connected as possible. So really focusing on YouTube for most of the streams, and then some of the streams are also adding in X and LinkedIn. But YouTube is the primary place we recommend people to watch the stream so that you can chat with most of the people. Then the second question was regarding Cosmos. So he asked if we're going to talk about Cosmos, which we announced during CES keynote with Jensen on Monday night. So we have a super exciting live stream planned for next week. Next week, at the same time as today, we are going to have a whole suite of guests, kind of breaking down different topics that were announced. And then we actually we're going to touch on Cosmos next week, and then we're going to have actually a deep dive, much deeper dive, where the whole live stream is going to be focused on Cosmos later on in just a few weeks. So we're going to post those ed event listings in the chat, so you can add them to your own calendar. But yeah, we're going to be having lots of special guests in the coming weeks, diving into many of the announcements that we did at CES. So we hope that you join us for those. Okay, well, Eric is getting his setup restarted. I'm going to go through here and look. And again, if you're basically just starting for the first time in Isaac Sim and Isaac Lab, as you can tell, the format for today is an office hours, which is perfect for if you want to share, want to learn about things from experts and also from the community. You can ask people in the chat. So it's much more casual kind of conversational than our typical live streams, which are kind of broken down very specifically with by topic and demonstration. So this is kind of more open-ended to kind of explore something together as a community. Next week will be kind of more of our more produced live stream, I'll say, where there's going to be those guest talk breaking down some of the things from CES. But anyway, for the office hours, definitely take advantage of the live chat. Let us know what you're working on. And then use this as only one of the resources that you can leverage in your journey into Isaac Sim and Isaac Lab. There's obviously amazing amounts of documentation that gets better every day. And we also actually have a documentation survey we'll post a link for in a minute. That reminds me. So we want your feedback on how you think the level of documentation is helpful to you. And that feedback will help us evolve the documentation. In addition to documentation, we all obviously have lots of great content on blogs, which are blasted whenever they're released. We put them on the Discord server, so you know when they're coming right away. And here's Eric, he's back, so I'll bring him back on. And then obviously we have great resources available in the community. It's the official forums, as I mentioned, on the GitHub, and also in our Discord server. So we hope you leverage all those different resources in your journey. And yeah, let us know if there's something missing or a gap that you're not seeing filled, and documentation. We'll do our best to fill it. Okay, Eric, welcome back.
Hey, so sorry.
That's okay.
Let's get my screen back up here, and let's see. Yeah, I don't know what happened there. I had my internet just completely died, and I had to restart my computer. Okay, so let's keep going down the path here of let's look at the Isaac Lab documentation. And what you'll find here, if you're getting started, is this really nice. Yeah, so we mostly are training robots. And when you do reinforcement learning, you often have a simulation that you run. And so you're going to run your AI through a simulation, and then that's where you do your training. And we are using Isaac Sim as our simulator in this case. And Isaac Lab is, I would call, our orchestrator. So the Isaac Lab, it sets up these simulations, it runs them, it interacts with reinforcement learning frameworks that are already written to handle like the hard parts of the training. And so Isaac Lab is an orchestrator for that. And you can use it for more than reinforcement learning. You can also use it for imitation learning, for example. And then once you get here, so in this documentation for Isaac Lab, there's this really nice documentation. And at first it talks about, how to write the code that will build a scene and spawn objects and that sort of thing. And these first, 1, 2, 3, 4, 5, 6, 7. These first number of tutorials are about that, and I found them pretty easy to follow. And I could run all of them. Okay, and then we get to this thing. It talks about manager-based environments and direct environments. And that's where I find people start to get a little more confused. And just to kind of clarify that, a direct environment is one where you have one, it's a little more procedural, a little more, I wouldn't say a script, you can still have classes, but everything is kind of front and center, and you write out one kind of compact set of classes that handle, getting observations from the simulation, controlling the robot in the simulation, interacting with the framework. And I would say it's a little bit easier to learn a direct work environment workflow. And then if you are doing a lot of it, like let's say you worked at a big company that did reinforcement learning, then you'd want to be able to reuse a lot of your work, and you'd want to be able to do really quick prototyping of different models. And for that, they've created manager-based workflows. And in manager-based workflows, it's more of like an object-oriented paradigm where you have classes that have inheritance that handle all of this stuff. And so if you worked at a big company that did this stuff, you would probably have, like, your company would have all of their classes, all of their base classes and ways of doing these things. And you could use their manager-based classes to do really quick and dirty prototyping and come up with some good prototypes and work fast. And so that's what a manager-based environment is really great for. But then if you wanted to get into the nitty-gritty and control every detail, like how the robots spawn exactly, then you would go back to a direct environment, because at that point, with a direct environment, you have more fine-grained control. So the people I've talked to, like at the bigger companies, they use a mix of manager and direct. And I would say for individuals, they primarily use direct. And I would say for me, I'm starting off with direct. I think everyone, if you're only going to learn one, I would learn direct because it's easier to start with, and the most advanced people use direct as well. But then if you work for a company and you need to do to work fast and efficiently, then you should learn manage your base as well. And so then I got to these tutorials on creating a direct workflow RL environment, and there are a lot of really nice samples of this. We've got samples of quadrupeds doing tasks, of cart poles, and this tutorial is about a cart pole, which is a simple robot. It's just mostly for education. It's a robot that can go back and forth and tries to balance the pendulum upright. And yeah, but I was having a hard time going from spawning scenes, creating scenes, to a full-blown RL environment and a direct environment. And so what I've done is I've worked with, Antoine helped me out, Antoine Richard, if you know him, and with some people inside here at NVIDIA. And I've done, so there's this create an empty scene tutorial, which just shows you the most basic stuff of how Isaac Lab works. I've written the most basic direct environment you can possibly make. And all it does is spawn the leatherback remote control car at random positions and orientations just every 5 seconds. Just spawns a new set of 16 of these. And that's it. Actually the cars drive straight forward, but they're not being controlled. It's just like the simplest direct environment I could think of. And it's just to show kind of that wiring and how you set up an environment. And I love the comments coming in. I like this one. Would love to learn how to transfer a trained model onto the Jetson Nano. And real quick, I'm just going to share. It's not into a Jetson, but yeah, I would love to do that too. I think we're going to get there. And a link to this tutorial. Oh yeah, you bet. Someone's asking for a link to the tutorial. Here's the Isaac Lab documentation. It has these other tutorials. This one I'm doing now, it is not outside this. You're in it right now. This is the link. We're doing it. So let me pull up Visual Studio and let's start going through this line by line. Actually, first I'm going to launch this, and so you can see what is going to happen at the end. I like kind of seeing the end from the beginning.
I like that.
Yeah.
People are sharing some.
What was that?
I was going to say people are sharing some cool projects they're working on in the chat. We love hearing about those. So some of those projects that you're working on might be a great fit for a blog or even a live stream. So definitely get in touch with us if you've got a cool story relating to Isaac Sim, Isaac Lab, OpenUSD, Omniverse platform, maybe it's a great topic to dive into live.
Okay, so I'm launching the Isaac Lab run. And what it's going to do is you create these little environments, and it's going to create as many copies as you specify. In this case, I said 16, but if you were really training, you would say like 4,000, 4,096, some multiple of 4. And then it's just every 5 seconds it's respawning these. And in a real one, you'd have some objective it was trying to complete, and you'd be giving it actions, and it would be measuring how well it did. And with every iteration, it would improve the models of these robots. And there's actually a sample. There's a sample that shipped with Isaac Lab of the Unitree Go 2, and you can train a complete new walking policy for that, a walking model for that from scratch in like 3 hours if you've got a
Wow.
high powered GPUs. But even with like a 4090, you could probably do it in less than a day, which is amazing. That just blows my mind. But so this is what we're going to have at the end of this, though. Ours just respawns them and has them drive a little bit, and it shows that we can make the motors go and turn the steering, but it's not training anything. And let's see, how much code is that? 150 lines in this class, and so like 300 lines of code. So not bad. Okay, I really tried to boil this down, and it could be probably a lot less than that if there were less comments. And you'll see I have some blocks commented out in here. That's because you can do things more than one way, so I've kind of showed both ways. So let's do this. All right. So, and if you go through the tutorial, if you're struggling with some of this, go through those first couple of tutorials until you get to the environments, and then come back. And I think that will help you a lot, because a lot of this is covered in those more basic tutorials. But we've got our imports that we're importing, all the Isaac Lab stuff, so that we can control articulations and have a direct environment and that sort of thing. These aren't too hard to get from the tutorials and from the samples. And then in this one, this leatherback config, this is our robot configuration. So if you're gonna spawn a robot, you need to have a configuration for that robot, and that's over here in this leatherback.py file. Is the configuration for the leatherback robot. Oh, sorry. I got to answer this one real quick. Great question. I get this a lot. What's the advantage of Isaac Sim over Isaac Gym? Isaac Sim and Isaac Gym are different things. Isaac Sim is a simulator. Isaac Gym is a reinforcement learning kind of orchestrator. And so it kind of automates Isaac Sim to run your stuff. And then Isaac Gym and Isaac Lab are they're kind of, Isaac Lab is the next evolution of Isaac Gym. And I would say, right, Isaac Gym is kind of purely direct environments. And right now it's a little bit faster at direct environment work, but it can't do managed environments. But if I were you, I'd work with Isaac Lab anyway, because we're still working on Isaac Lab. It's the one moving forward. And so over time, it'll get faster than Isaac Gym and support more things. And
yeah, technically Isaac Gym is no longer being supported. It's all Isaac Lab.
Yeah, that's right. So let's see here. Let's take a look at this. Let's take a look at this here. So let's look at the configuration first and just go line by line here. These are the parameters that you absolutely must set. There are other parameters, and this is kind of like the configuration class is one where you just set these parameters that you're going to use. This other class is where you define the functions that do stuff in between runs, is the way I would describe it. And so decimation, you'll see when we create the simulation, we create a time step. The decimation is for every so many time steps, how often are you going to apply actions and gather observations and do all that stuff. And we're saying every two time steps. The episode length is how long in seconds each episode is before it resets. And if you're having some problems with your physics simulation, one really great tip is to make this a long time step. And that way you'll have a lot of time to try to see what's going on and play around in the scene while it's running before it resets. I have these at 0. Let me just, sorry, 1 second. I thought I had those at 1. Oh, no, I have it at 0 and it's working. And this is wild, but your action space is how many actions your AI should do. And this is the output, the number of outputs from your neural network. And I have 0 here, which means I have a neural network that's not doing anything. It doesn't have any outputs. And which is, yeah, to be honest, it's a little bit iffy, because if I was trying to train a neural network that didn't have any inputs or outputs, it might crash. And so I'm actually, well, I'll leave it for now, but I'll probably change this before I release this to be 1 action and 1 observation. Actually, I can do that. I know how to do this. I'm going to do that right now. I was goofing around before this and I changed it back. And because I want a neural network with 1 input and 1 output, I just feel like that could lead to bugs later on. So, and all I have to change, and we'll get this later, but I just don't want to forget this. Get observations, you need to be a 1. Okay. So, and then our state space, you need to define this value, but state space are basically observations that you use to train your neural network with simulations, but will not be available in the real world. So you can measure all this stuff. You can measure all this stuff in sim that you couldn't get in the real world. And so you can use that to your advantage. And that's what state space is. Great question coming in. Lots of great questions, but I just we'll only have like 20 minutes and we have a lot to cover. So I hope you all will join the
study group.
The study group.
Yep. Later today, actually.
Yeah.
1 hour from now, actually. 1 hour from now.
Yeah.
On our Discord server.
So what is the observation space? In this case, we're just defining we don't really have an observation space because we're not doing anything. We're not observing anything, but I'm just putting 1 in, and we're essentially going to pass a 0 into the neural network every time and get a 0 back out probably, or whatever random values the neural network wants to give us, but we're not going to do anything with it. This is the simplest example I could come up with, right? So we're not giving the neural network anything of value. We're not getting anything back. I just do feel like if we actually had like a completely null neural network, that could cause bugs later. So I'm going to give it a 0 every time. Okay. So here we configure the simulation. We're saying our time step is 60 hertz. And we set our decimation to be, every second frame. It will take actions and stuff. In here we define. We're saying here that for our articulation configuration, so you need to have at least some robot for a direct environment. We're saying it's going to be the leatherback config, but we're going to replace the default prim path with this one. And note that there's a little dot star. That just says that's a regular expression. And that's saying if we create 16 environments, it'll just put that index of 1 through 16 for each of those in our USD. And then just to make it move forward and steer, we define the degree of freedom names. These are the names of the joints that represent the individual degrees of freedom that we're going to control. Okay. Here's the throttle. Here's the steering. And then finally, we've got this interactive scene. I guess the default's going to be 4,000 environments. And they're going to be 4 meters apart. Yeah. And this replicate physics true flag, I think we just leave it as is. Unless you're going to really dig deep and you're a very advanced user, I've heard. So there you go. That's the configuration. Are there any questions about the configuration? And great questions from I want to make sure I remember to answer this from the Robotics Club, is what happens if you put a breakpoint? I'm going to show you, if we get to the end, how to run this and how to debug this so that you can put breakpoints and it does not break things. It's wonderful for debugging. So great question. Okay, if there are no questions, great question. Shouldn't the action space be 6 in this case? So this is the difference between the model and the policy. The model is, the action space is the output from our AI model. It's the numbers that the AI outputs. That is the action space. And we're just going to say 1 because it's the simplest number that I feel comfortable with. The policy is the code that takes those actions and does stuff. And our policy is don't do anything. And so we're just going to ignore the action space completely. And our policy is not to do anything with the action space coming out of the AI. In this really simple example, this is obviously that would be terrible for actually getting a robot to do anything. But I'm just trying to show you how a direct environment is set up. Great question. And you'll see here, actually, I'll kind of fast forward to that just because of that question. For our apply actions, so here you'll see the functions that do all of the things that it needs to do. And for our apply actions, we are not doing anything with the output from the model. And we're just telling it, excuse me, we're setting the joint velocity of the wheels to go forward. And we're setting the joint position of the steering to be turned, I think, to the right a few degrees. So great questions. Okay, so let's take a look at this. This is the configuration. And this class defines how everything works. Like during, it defines all these functions that actually do stuff during the run. And in it just initializes anything we need. In this case, we're going to need to know, we've got these names here. And these functions go to the load-back configuration and give us back the joint IDs, the indices of each of the joints that we might want to control. So we have our throttle indices and our steering indices. That's all that's doing. Setup scene, it defines each of those individual scenes. It's our initial setup configuration. In this case, we've got a leather back that we're going to configure. So we get that variable. We spawn a ground plane. We configure how to clone and filter clone the environments, and we decide whether or not collisions are filtered. This environment cloning one, if you change this copy from source, that you're getting into very advanced territory. So you'll want to, I intend to use that line as is for a long time. Filtering the collisions. Yeah, that one can get a little tough to work with because there are 2 places where we filter collisions. That's a setting in the articulation in OpenUSD and a setting here. So I don't have great guidance on if you want the things to collide with each other. I don't have great guidance on that at the moment, but I think it can be done. Yeah. Here we go. Here we're setting the scene articulation to be that leather back. And then we're adding some lights. Now this setup scene is covered pretty well in those previous tutorials, or excuse me. And so I feel like if you run through those, this is pretty understandable, this setup scene part, okay? Okay, so next, pre-physics step. So anything that happens before each physics step, and we're not doing anything here because we don't need to. So, but this function does need to be defined. It just doesn't need to actually do anything. Apply actions. I've showed you this already, but here, like I said, we're ignoring the actions. We're not applying the actions, really. Our policy is to just have the car drive forward and turn to the side. So we're doing that just for simplicity. Now for get observations, remember the observations are what's fed into the neural network. And what I'm doing is for each environment, I'm saying I'm giving it an observation of 0, no matter what. I'm not giving it any. This is where for the observations, you give it all kinds of data, about the environment. If you're working with a camera, you'd give it like the images from the camera, that sort of thing. But we're just always giving it zeros, so it's not doing anything. For get rewards, once again, we're just returning a bunch of zeros. But we're returning as many zeros as there are environments. One zero for each environment. And each of those is a float 32, and each of those is on the GPU. So it's important that these rewards and actions and observations are structured correctly so that Isaac Lab knows how to work with them. And so, yep. In this case, for example, in this case, it's a two-dimensional array with one. It's kind of, yeah, you get into some torchy kind of stuff, and sometimes PyTorch will need to have a two-dimensional array, and sometimes it wants a one-dimensional array, and so having, this right here, I'm sending it all zeros, but this first argument defines the shape of that. In this case, it's an array it's a two-dimensional array that's the height of the number of environments and the width of the number of 1. And if I put, you get some subtle differences, like if you just don't put an argument there, it'll actually be a one-dimensional array. Or if I put a 0, look, if I put a 0 there, it's actually a one-dimensional array that's empty, or a two-dimensional array that's empty. And it gets weird if you're working with 0 observations. But so that, so the shape of this array is important. The data type is important. And putting it on the GPU device is important. Then for observations, we turn that into a dictionary. We actually return that dictionary to Isaac Lab. And then get rewards is we're just returning all those zeros. And that's saying, that means no matter what the robot does, it's not get a better or worse result. But this is where you would define, well, how well did the robot do that run, and return those values so that the RL framework can optimize it. And it's not actually, Isaac Lab just orchestrates all of this. It doesn't actually do the training. Isaac Labs it follows this gymnasium specification that has been open sourced by OpenAI. And there are quite a few reinforcement learning training frameworks that also work with the gymnasium specification. And so it's nice because you set all this up, and then there's like a dozen different RL frameworks you could use to actually do your training. And so once you have this set up, because this all fits just like an open specification for how the rewards are defined and how the observations and such. Okay, get dones. This tells us how does Isaac Lab know, or the RL framework know, if one of the environments is done simulating. And that can be done cleanly, like the robot finished the task, or it could be the robot ran into something and fell over, and that's a failure termination. But we're going to return, let's see, for the clean termination, we're just returning if it kept going for the whole time. And for the failure termination, we're just always returning false, because it never fails for us. And finally, reset index, this is the code that resets given an environment index, it could reset just that's one environment, or given an array of indices, it would reset all those environments. And we're going to calculate how many environments have been passed into this function for use later. And then we can reset manually or reset from this configuration file. I think this is going to be the more typical way to work. You can define the initial state and all of that in the leatherback configuration file, and I'll show you that in a minute. And you can just pull the values from that default file, and you can use those. Or if you want to do resets from scratch in a little more sophisticated way, you could do that all by hand and manually do whatever you want. And so here we're setting the we're getting the default state from this robot configuration class, and then we're getting like the pose. The first 7 elements are the XYZ position, and then the WXYZ quaternion rotations, and the velocities. So there are 6 of those. Those are going to be your linear XYZ linear velocities and your XYZ rotational velocities. And yep. So then we're going to get the scene pose. We're setting a slightly randomized starting position. So we just grab. So the pose is the kind of the default origin of each environment. So if we take this pose and we take the XYZ position, and we're going to add on the position of each of the individual environments to put each one at the center of its own environment instead of at the center of the whole scene. And then we're going to add on a little random modifier to randomly position each car, a little bit off center, just to show a little bit of randomization. And then we calculate a random set of angles, one for each of the cars. And we are to apply an angle to a quaternion. If we want to rotate about the z-axis, we're going to apply parts of that angle to the W and the Z components of the quaternions. I know I'm going so fast here. I'm sorry. And we could go over this again on another series if you like, another session. We just got 6 minutes and I've got some ground to cover. And then we write those positions and velocities and joint states all to the robot. And that's what makes it reset nicely. So with that, let's look at the leatherback. This is the actual robot. And here we've got the robot is in the repository as a USD file. But you can come up with root paths to nucleus and servers and stuff if you'd like. But here's where it is. Here's some standard rigid body properties to define how the rigid bodies will work, how the articulations will work. Here's where we define that initial state that we were drawing from in the reset function. And then here we define here we define where the actuators are, where those joints are in the file. And it looks like you can use those regular expressions there as well. It'll just grab any wheel, any of those wheel actuators based on its index, which is nice. And then, so that's that. And then in the init, so that's our environment definition and our robot definition. In this init file, this is where it gets registered with Jim, and this is the name of the actual thing that we're going to launch through the command line. And then here's where we kind of hook up or kind of wire up where everything is. So how it knows, if I give it this environment name, what should it actually launch? And that's where this is, and that's where this is, and those define those entry points. And then these, depending on the framework, the RL framework you're going to use, in this case, we're going to be using RL games, but you could use this configured to use any of these frameworks as well. So that's that one. And that's enough to go ahead and launch this. And let's try it. Let's just go through the command line arguments you run here. So to run a direct environment, I'm running in a Conda environment, and so I'm running it the Python line directly. I'm running Python directly, and then the Python file you're running is actually this. In this case, it's a random agent. It just does random stuff. It's a simpler agent. It doesn't actually do training, but you could. This is where you would put the RL games training file if you wanted to use that instead, for example. And the task is that task that was in the configuration above. And then we can set the number of environments. And if you follow those tutorials above, you'll see how to add some different environment variables to this if you want. But this seems to be the kind of the typical. And if we run that directly in that way, 3 minutes. And I know I'm going fast, but you all can come back and reference this stuff after the fact and to help you get through that. There we go. So we have a working, super basic RL direct environment that doesn't do anything. So let's close that. And finally, I promised I'd show you how to run this in debug, which is really handy. And let's just put a breakpoint somewhere. Let's put that into like get observations, for example. And then what I've done here is if you look in the VS Code tools portion of the project, there's this launch.json. And you can see how they've done it for some of the other debug launchers. And I'm just saying, I'm going to launch, I'm going to name it Leatherback 1. It's going to run Python. It's going to run a Python. It's going to run Python. And then these are the command line arguments. And this is the Python program it will run. These are the command line arguments. And you can see I put those same command line arguments, but here. And so then when I go to debug and look at this list, I've got Leatherback 1 here. If I launch that, it's going to launch it, but in debug mode, but attached. Just wait for it. And you'll see it's going to launch it. And we've got debug break, no problem. I can use all that nice debugging, all those nice debugging features of VS Code that I love. And we can continue. And it's all good. It all works. So there we go. We're out of time. I guess we could, I could answer one or two more questions if we can go over a little bit, but I think.
Yeah, we can. And we also have the study groups that's starting in 30 minutes from now. So I have a couple of quick suggestions for people. So a lot of great questions we asked today. There's a couple great places to follow up with these questions. If the questions relate specifically to what Eric showed today with learning reinforcement learning, I would highly recommend you use the thread I posted in the chat. That thread is specifically for today's live stream. So anyway, you can talk about it today, tomorrow, next week, and it's all on this topic on this live stream. If you have another general question on Isaac Sim or Isaac Lab that doesn't relate to this specific topic, then you should go to either the official Isaac Sim support forum, if you want help from NVIDIA devs. For Isaac Lab, go to the GitHub discussion thread. I posted both these links in the chat. If you want to chat with other community members on Isaac Sim or Isaac Lab, both those have their own individual channels on the Omniverse Discord server. So that's the place to go to chat with other users. So a bunch of different places depending on exactly what you're looking for. And we would love to kind of continue the conversation on Discord, of course. The great resources too. I have to also mention that we have a couple of fantastic, well, bunch of fantastic people watching, a lot of new viewers, which is awesome to see. And a couple of people wanted to point out that have produced some great tutorials. One is Shane Reitz, who's in the chat right now. Hey, Shane. He has a great LinkedIn feed. I'm going to post one of his links here. I highly recommend you guys check out. This one is actually just getting. I think this was getting started on an Isaac Sim, I believe, or Isaac Lab. Check out this post with this great video that Shane produced, and he's got others too. That's a great resource. And then very happy to have Lychee here. I hope I'm not mispronouncing your nickname. He's got a great YouTube channel with lots of great videos. I'm going to post that right here too. Both these are great resources. These are from the community. These are developers out there in the world doing really cool stuff and sharing that knowledge with everybody, which is awesome. We'd love to see that. So I would definitely subscribe and follow these folks. Really, really talented individuals that are producing amazing content, helping others that we strongly encourage people to check out. But yeah, so Eric, do you have any more closing words before?
No more closing words. I guess I know I went through that really fast, and I hope you all join us in the study group. I think we'll be talking about some people's projects. I think we'll be looking at this and starting to apply some actions to it and training it to do some simple tasks. It's kind of our next steps, and we're doing it together. I'm learning too, so. We're all doing it together. Everyone's welcome.
Yes, definitely. And these office hours are great. Like I said earlier, this is really more of a casual kind of show and tell, meant to be interactive. Next week we have a more produced live stream with some guests going over some of the CES announcements. So that's going to be a little less conversational and more like going over the features we talked about. But we'll still be taking your questions. But these office hours are a great way to kind of learn with us. And in the vein of Ashley's also series from last year, Learn With Me, to kind of figure stuff out along the way with the community. So happy to have everybody here joining us. I hope to see some of you in the study group that kicks off in about a half hour from now. And on the Discord in general, feel free to use that to chat with other people you're seeing the thread today. And Eric, thank you so much for doing this and being a host of our first live stream of 2025.
Thank you. I love it. I love being on these live streams. It's so fun.
Well, it's a great experience for everybody. So thank you everybody for watching. We'll see you next week when we talk about some of the CES announcements. If you can join us on Discord server in a few minutes, that would be great. Great to see so many new faces. We will see you soon. Thanks, everybody.